In this video, we explore the concept of measures of dispersion, an essential topic in statistics that helps us understand how the data is spread around a central value. Measures of central tendency such as mean, median, and mode are used to summarize data and enable us to compare two or more groups. Suppose there are two groups of students with the following marks. Group A 48, 49, 50, 51, 52, and Group B 10, 30, 50, 70, 90. Here both groups have the same mean mark 50. By simply looking at these mean values, can we say that the two groups are similar in their performance? No. Why? In the first group, all students scored a mark close to the mean value 50, whereas in the second group, the marks are widely scattered. This indicates that mean alone is not sufficient to summarize the data completely. Along with the central value, we must also describe how much the observations vary or deviate from the mean. Only then does the summary representation of the data become complete. Measures of dispersion describe the degree of spread or variability of observations around a central value. They are also called measures of variation or measures of scatter. There are several measures of dispersion and the simplest among them is range. So range is obtained by maximum value minus minimum value. Here for group A, range equal to 52 minus 48, 4, whereas for group B, it is 90 minus 10, 80. So range is the difference between the highest and lowest in a data set. It is very simple to calculate, but it only uses two values, so it may not give the full picture. So in statistics, sometimes the range is not enough to understand the data spread, especially when extreme values are present. In such situations, we can use a better measure called interquartile range or IQR. Interquartile range tells us the spread of the middle 50% of the data. It focuses on the central part of the dataset and ignores extreme values, making it more reliable. Let us understand this step by step with an example. Consider this dataset 10, 20, 30, 40, 50, 60 and 70. First we find out the median. Here the median is 40. Now we divide the data into two halves. The lower half is 10, 20 and 30 and upper half is 50, 60 and 70. Next we find out the quartiles. Q1 or the first quartile is the median of the lower half, which is 20. Q3 or the third quartile is the median of the upper half, which is 60. Now we calculate the interquartile range, which is equal to Q3 minus Q1. Here it is 60 minus 20, which is 40. This means the middle 50% of the data lies within a range of 40 units. The key advantage of IQR is that it is not affected by extreme values. So it is very useful when data has outliers. In simple terms, interquartile range helps us understand the spread of the most important part of the data. Next is variance. Now let us understand variance using this simple example. Here we have the heights of 5 children, 125, 122, 118, 123 and 127 centimeters. First we calculate the mean height, which is 123 centimeter. Next we see how far each child's height is from the mean. The child with height 125 is 2 units above the mean. 122 is 1 unit below the mean. 118 is 5 units below the mean. 123 is exactly equal to the mean, so the deviation is 0. 127 is 4 units above the mean. So these differences are called deviations from the mean. Variance measures the overall spread of these deviations. If the values are very close to the mean, the variance will be small. If the values are spread far away from the mean, the variance will be large. So in simple words, variance tells us how much the data values vary or spread around the mean on an average. So it uses all data points, makes it more reliable than the range. Let us do the calculation of variance. The formula for population variance is given by sigma square equal to sigma x minus mu whole square by n. And the formula for sample variance is given by s square equal to sigma x minus x bar whole square by n minus 1. Now let us calculate the variance step by step using this table. So look at the data values 118, 122, 123, 125 and 127. The mean of these values is 123. To calculate variance, we first find how far each value is from the mean. So this is shown in the column x minus 123. So for 118 deviation is minus 5, 122 it is minus 1, 123 deviation is 0, 125 deviation is 2 and for 127 deviation is 4. Some deviations are negative and some are positive. So if we simply add them, they cancel each other and become 0. To avoid this problem, we square each deviation. That is shown in this third column. So minus 5 square becomes 25, minus 1 square becomes 1, 0 square becomes 0, 2 square becomes 4 and 4 square 16. Now add all the square deviations which is equal to 46. So since this is treated as a sample, we use the sample variance formula. So sum of square deviations 46 divided by n minus 1 which is 4. So that gives the sample variance as 11.5. So this value tells us how much the data values are spread around the mean. So a larger variance means data are more spread out while a smaller variance means data are close to the average. Now let us understand why we divide by n in population and by n minus 1 in sample variance. First imagine we have the heights of every student in a class. If our population is this, we use population variance formula or divided by n, which means the total number of observations. Here n represents the population size. Because we know the true population mean there is no estimation involved. Now let us see what happens with a sample. Suppose a school has 1000 students but we only select 200 students to estimate the average height. This is called a sample. Since we do not know the true population mean, we estimate using the sample mean. Here instead of dividing by n, we divide it by n minus 1. Why? Because the sample mean is only an estimate and using it make the variation appear slightly smaller than the true population variation. So dividing by n minus 1 corrects this problem. Let us take a simple example. Suppose our sample values are 2, 4 and 6. Here the sample mean is 4. Now calculate the deviations from the mean. 2 minus 4 gives 2, 4 minus 4 is 0, 6 minus 4 gives plus 2. Notice something important. If we already know 2 deviations, the third one is automatically fixed so that the total becomes 0. So that means only 2 values are truly free to vary. So for 3 observations, only 3 minus 1, 2 values that are free to vary. This is called degrees of freedom and that's why we divide by n minus 1 instead of n. So remember, use n when you have the entry population and use n minus 1 when you are working with a sample. However, the variance is expressed in squared units, which can be difficult to interpret. Since the variance is expressed in squared units, it is not comparable to the original data values. For example, if height is measured in centimeters, the variance will be in square centimeters, which is difficult to interpret in real life. To bring the value back to the original unit, we take the square root of variance. This gives the standard deviation. So the population standard deviation is given by sigma equal to square root of sigma x minus b whole squared by n, and sample standard deviation is given by s equal to square root of sigma x minus x bar whole squared by n minus 1. So in this particular example, the variance is 11.5. So the standard deviation is square root of 11.5, which is approximately equal to 3.39. This means that on an average height varies about 3.39 centimeters from the mean height. So variance gives the spread in squared form, whereas standard deviation gives the spread in the original unit, making it easier to understand and interpret. Standard deviation uses all data values expressed in same unit as the data. So it is widely used in research, medicine, and data analysis. Averages alone are incomplete. Variability gives the full picture of the data. Thank you for watching. If you found this session useful, please like, share, and subscribe for more statistics classes.